Okay, 4.5 student notes, sinusoidal functions of mathematical models, day 3. And if you notice these notes have 3 problems on it, I'm only going to do one of these in the video lesson, and your assignment tomorrow is actually going to be the next 2. And so each time we have one of these, difficulty level is going to just get stepped up a little bit. And so let's just proceed, and if you have any questions, please just jot them down and ask them in class tomorrow. Okay, so according to biorhythm theory, your body is governed by 3 independent sinusoidal functions, each with a different period, as follows. So physical function, the period is 23 days. The emotional function, the period is 28 days. And intellectual function, the period is 33 days. And it says we're at a high point in all 3 cycles today. This means that you're at your very highest ability physically, emotionally, and intellectually. Okay. So what's going to happen is after today, things are going to start going down, but at different rates for the physical, emotional, and intellectual. And then at, on another day, just because the period is different, on another day you could be the lowest intellectually, but doing pretty good physically and emotionally. And this is a theory, so regardless of whether you agree with it, we're just going to go ahead and answer the questions that has to do with this theory. It says the amplitude of each sinusoid is 100 units and the vertical displacement of each is 0. This vertical displacement, they might as well have said vertical shift or the sinusoidal axis. Write equations for these 3 functions in terms of the number of days after today. Okay, so I'm going to start by graphing them, and I'm going to do this all on one graph. It's always easier to graph and then write your equations. Okay, so this has to do with the days, the x-axis, the independent variable. Let me go back to regular pen here. Days. So that's our x is number of days. And then the y-axis is going to be our ability. Okay. So highest is 100. They told us that. And since our vertical displacement is 0, then the lowest I'm going to go to is negative 100. Okay, now I know that for the physical, I start at the top. Okay, so on day 0 today, or after 0 days, I'm at 100. Okay, 23 days from now, I'm going to be at another peak. So what's going to happen is the graph is going to go down below, and it's going to go back up, and I'm going to be at another peak at 23 days. Okay, I'm going to switch colors here. Let's just do, underline this or something in red. Let's use a different color, blue. This will be our emotional. So this period's a little bit longer. It's 28. So I'm going to mark a 28 here. And again, day 0, starting out, I'm at 100. I'm going to be back at 100 after 28 days. So in graphing this, it's stretched out just a little bit further. And, I don't know for sure if this point is after 23. I could do a little bit of calculation, but I'm not going to worry about it too much. Okay, now let's do green for the intellectual. Okay, this is the longest period. This is 33. And again, starts off at 100. Okay, after 33, back at 100. Again, I'm not going to get too caught up in the details of where these low points are. I'm going to plot this in my calculator in a minute, so that way I can get a better picture anyway. But if you notice with these 3 graphs, they all have something in common. In fact, they have almost everything in common except for the period. So in going back and writing our equations, you have y equals, there is no vertical shift. The amplitude is 100. Definitely going to use cosine here since I'm starting at a peak. The b value is going to be different for each one. So the first b value is going to be 2 pi over 23. Now that does not simplify. Let me make sure that's clear here. 2 pi over 23. All right. And I'm going to go ahead and put X here, or you could put T for days. There is no horizontal shift because you're starting at the peak. So when going to my next one, it's going to be almost the exact same. For the emotional, it's 100 cosine. Now this time I'm going to do 2 pi divided by 28, so I'm going to go ahead and simplify that to be pi over 14 x. And then the last one, the intellectual, y equals 100 cosine 2 pi over 33x. Okay, so I have my equations. Let's go ahead and graph it on the calculator before we move on to the other questions that they have. Okay. Okay, so I have 100 cosine, and I'm going to go ahead and still do the double parentheses. 2 pi divided by 28 x. I'm sorry, 23. I knew that didn't sound right. Okay, 23. And for my y2, I'm going to have 100 cosine. It's always good to practice this along with me instead of just watching me do this. That way you're getting the practice on the calculator. Okay. If I go into my window, well, let's first make sure we're in radians mode. I am. And if I go in my window, I'm going to go and let that be -5, and I'm going to let the x max be 40 so I can at least see one good cycle. I might have to change that later. And then my y min needs to be at least -100. I'm going to let it be -110. And then my y max needs to be 110 as well so I can see the top. Okay, so there is my first. Here's the second. Looks pretty much like what I drew. Notice that's a little bit more stretched out. And then here's the one for intellectual. And it's even more stretched out. So it looks pretty close to what I graphed. It might not be a bad idea just to double check these and make sure that the period is correct. I can see that they all start at 0, 100, which is right. But if I type in 23 and my y1, I should be up at the top, and I am. And if I push the up button, I can go between y1, y2, and y3, or down. And so if I'm on y2, I need to trace 28. Make sure that, oh, I got back on y. I was like, why isn't that? There we go. Make sure I'm on y2. I guess I got to do trace, then down to y2. 28. Make sure I'm back up at 100. And then I need to trace, and I need to go to y3. Make sure that that period is 33, like how it's supposed to be. Okay, so I'm pretty confident in my graph. All right, so let's go through and answer the questions that they have. So B says, 33 days from now, you will again be at an intellectual high point. And we know that. That was the green graph, the third one we drew. What will be the values for your physical and emotional functions on that day? Okay, so we can, we're already right here, so I can move my arrow up or down, and I can do trace 33 and enter that way. I can go on the table, and I can look it up, and I can do y1 of 33. Let's practice this, because this is something that I'm not sure students get enough practice at. Vars, y1 enter of 33. Okay, that's going to be my physical, so that's -91.721. So I'm going to say for physical, -91.721. And then for emotional, I would do vars, y-vars. And again, this is not the only way to do this. You could have done this on the table. Oops. I forgot to type in the value. Vars, y-vars, function y2, and then of 33. I'm not doing y3 of 33 because I already know it's 100. So that's going to be 43.5 388. So my emotional is going to be 43.388. Okay. And then you could do that for any other day that you wanted to. So notice that really good intellectually, doing pretty bad physically, and I guess so emotionally. All right. Part C is a little bit more interesting because it gives us some more information that we can apply. It says biorhythm theory states that the most dangerous time for a particular function is when it crosses the sinusoidal axis. So this would be when the y value is 0. Possibly this could be because you're going from being on the positive side to being on the negative side. So if from being a good day to a negative day, it's kind of like when you turn that corner is the most dangerous time. When is the first time this will happen for each of your physical, emotional, and intellectual functions? This is probably going to be easiest answered using the calculator. And I'm going to go through and put into y4, 0, and then find the intersections. Now when I press graph, it won't seem like anything's happening because it's just plotting the y equals 0 line. And I'm going to go ahead and do second trace 5. Now when you're doing this, you need to make sure that you're finding the intersection. First off, of the two lines that you want it to do. Second off, where you want it. Okay, so I'm going to go ahead and move the left cursor over because it says the first time this happens. Alright, I'm already on y1, which is good. And when it says second curve, I don't want to find the intersection between y1 and y2. I want to find the intersection between y1 and y4. Now, I also could use the 0 function. This is probably, though, what you're most used to, so we'll stick with this. So at 5.75 days, that's that dangerous time this theory is talking about physically. Alright, so let's go ahead and write this down. 5.75. I'm going to go ahead and stick with the colors that we're using. So for physically, 5.75 days. Okay, now let's do emotionally. Same thing. Second trace 5. This time I need to move the cursor down to y2, enter. And then for second curve, I need to go to y4 again, enter. And then you can just do a quick check, make sure that y value is 0 so that it's legitimate answer here. So 7 days, and maybe you could have actually come up with that on your own, considering that number was 28, and you could have divided by 4, and that's really what we could be doing for all of these. Okay, so let's check that out. Let's write this down and let's see if that would have worked for the physical. Could we have just divided by 4? Alright, well what is 23 divided by 4? Let's cut out of this. 23 divided by 4. This is just using the understanding of critical points. And so to find the third one, I'm going to go ahead and do 33 divided by 4. So lots of different ways to come up with your answer here. 8.25. Could have also used the calculator. So intellectually, 8.25 days. Okay, the last question is actually probably the most interesting one. It says, how long will it be before you are at another high point on all 3 cycles at the same time, like how you are when you start timing, day 0. So if I press a graph, I can see that it's all 3 together right here, and then as it goes on, you kind of run into trouble. Now, I have seen students before hit the trace button and go to the right, and what they're wanting to do is just kind of see if they can go right far enough and to where they can see it. Other students say, oh, I know a shortcut. I'll go to the window and I will extend the window out, and then everything gets scrunched up and it may take a long time. And other students say, you know what, table's the easiest way. All you got to see is when is it going to be 100 on all 3. Now, if you do any of those, it will take you a long time, a really long time to do that. These 3 numbers don't really line up at 100. Now, you may get where 2 are 100 and 1 is close, but it says all 3 have to be on 100. So let's think about this a little bit more logically using numbers. Okay, so remember, I'm going to jot this down. Remember that the period for the physical was 23 days. For the emotional, I'm going to go ahead and keep in my color code here because I think it'll help keep them all separate. For intellectual, it was 33. All right, what you're looking for is cycles of 23, 28, and 23 that will all line up. And really, when I say cycles, numerically, I could be just saying multiples. So every multiple of 23 is when physical will be at 100 ability, level 100 ability. Every 28 days, it'll be at, emotional will be at 100 ability. And every 33 days, or multiples of 33, it will be intellectually. It'd be at level 100. Okay, so these three numbers really don't share a lot of common multiples, but that's what we want to find. We want to find the common multiple, and since it's asking us in the way how long will it be before you are at, they want to know the first one. So this is called least common multiple, and this takes you back to elementary school. This is just one real life example of when you would want to find the least common multiple. Okay, so just to kind of review how you do least common multiple is you want to find common factors and not repeat them, because otherwise then you will come up with a common multiple, but it won't be the least one. All right, so 23 is a prime number, so to find a common multiple between 23 and either of these, you would have to just multiply them. 33 is not prime, but I want you to think about this. 28 can be split up into 4 and 7, and 4 can be split up into 2 and 2, and 33 can only be split up one way, 3 and 11. So I want you to think for just a second. Let me make this actually look like a 3. I want you to think for just a second about how many multiples or factors these three numbers share. Basically 23, 2, 2, or 4. We don't really even have to split it up since there's no repeats. 7, 3, and 11. You're thinking right now, how do I find, by hand, the least common multiple of these numbers? Right, they don't share any factor, so hopefully you came up with just multiply them together. Now, multiplying these three numbers together, 23 times 28 times 33, would always come up with a multiple. That would come up with a day when you're at a high point. Although it's not always the least common multiple, in this case, though, it is, because these numbers, none of these are repeats, okay? If instead of 23 here, this number had been 24, and you would have had, you have a 4 in there, you have a 3 in there, then that day would actually come sooner than this. All right, so we need to multiply 23, 28, and 33. So 23 times 28 times 33. All right, so that's how long you would have had to scroll on your graph or on your table. 21,252, that many days. All right, now I'm not going to do a whole lesson on least common multiple, but one more thing I want to show you is your calculator knows how to do this. If you hit the math and you go over to number, and I just hit the up button because I knew it was at the bottom. So math, let me repeat this, math to the right to number, then you can either scroll down or up to LCM. You can also find this on your catalog if you've forgotten it. Now, your calculator, only does 2 numbers. So you would have to find the least common multiple between the first 2. And then you would take that number and find the least common multiple between it and 33. Okay, so this is just a way we can check our answer. So 644, 33. and you get the same answer. This right here would be very useful if you had numbers that shared a lot of factors. So in the future, that might be more useful. In this problem, we kind of lucked out. All right, now one quick thing is you have 2 more examples on your notes. We're going to do those in class. They are kind of a step up. They're all just using what you know and what you've learned before. We're going to do them in class though, so you'll have plenty of time to ask me questions. If you're though having issues with the most basic things about this, like how to come up with the equation, how to check the equation in the calculator, how to manipulate the table, how to do the vars, y vars, really we need to get that taken care of first, because on the next 2 problems we do, we're gonna go through that part pretty quickly. Okay, bring your questions to class.